Alright, so this week is very similar to the last 2 weeks. We are still doing hypothesis testing and confidence intervals, except now we are doing 2 samples instead of 1. All the same rules still apply. I am going to do a few examples with StatCrunch to kind of help us with the technology and see how we use it with this week's lesson. The first question we'll do here is number 3. Alright, we're going to conduct a test of alpha 0.01, level significance. They're going to ask us to find these things. They're independent from a large population using simple random sampling, which tells we can use the rules we've been doing. And test whether P1 is greater than P2. So right there tells me I'm doing proportions because it's P. So I'll come over here on StatCrunch. And we click on Stat, Proportion Stats. So the last 2 weeks we've been doing 1 sample. Now we're in 2. Here it is again with data or with summary. For this problem we have a summary of our, so we do with summary. And we'll bring it down so we can kind of see what we're typing in here. So as you can see here, it says the sample data are X1, which means that's from sample 1. So I will put in our success of 129. Our sample size N is 256. So sample 2, 135. And sample size is 305. I'm going to shrink this down so now I can see both here a little bit. Yeah, I think that'll be good. Move this up here for a minute. So we're doing hypothesis testing. You notice what's in StatCrunch is a little different than what's in the homework. Only difference is StatCrunch has set it up where we take one population, a point estimate, and we subtract it from another. In the homework, they are saying they're equal. Well, if I subtract them and I set them equal to 0, well, if they're equal and I subtract these two numbers, I should get 0. StatCrunch allows this for a little more flexibility in case you want to say 1 is bigger by some different value. For this course, we're always going to assume to be 0. And then they tell us what our alternative should be, greater than. So remember, the null is always equals, which is why we can't change it. The alternative, we have to read our problem and decide if we're doing greater than, less than, or not equal to. In this problem, they tell us which one they want. Others, they won't. Again, I recommend you click on p-value plot so you can see the p-value graph. So it's a nice visual thing. It's not required, but it helps kind of understand what's going on. And then we can click compute. Click on that to make this a little bit bigger. So this is a good summary of what we're trying to find. There's our null and alternative, which is similar to what we answered in the homework. The first couple points of data here are what we typed in. The sample difference and the standard error those are allowed or calculations if you want to go do the formulas by hand that are in the announcement. But StatCrunch has already calculated it for, and so here's our z-stat, which is our test statistic. So they wanted us to type in here. Always be careful and read what they're asking for, so 2 decimal places. So I would round 1.448 to 1.45. And then they've calculated our p-value for us. So then we can put it in. Some problems are going to want p-value, some are going to want a critical value. Make sure you review last week to see how to do critical values. I put page numbers in the announcement so you can go to each section, which give you a breakdown of how to do them all. Plus I put in how to do it in Excel. Alright, so now we compare our p-value, 0.07, to our level significance alpha, 0.01, and you can see 0.07 is bigger than 0.01. And according to the rules, we do not reject the null because there is not sufficient evidence to conclude that P1 is greater than P2 because our p-value is less than our level significance. So very similar to what we have been doing all week. The rules are the same. There's no change in what we're doing. It's just the formulas are a little different, and we're doing more than 1 sample now. Let's do another problem with data. So I think question 6 possibly. No, of course. There we go. Here's one, and it's also one they want us to build a confidence interval for. So we'll do kind of both with these before. The following data is a muzzle velocity in feet per second of shells fired from a 155mm gun. For each shell, 2 measurements of velocity were recorded. So because each shell, one gun is firing 1 round, and we're just using two different measuring techniques, this data should be paired, which is why they ask us in this. So we're going to use the data and open in StatCrunch. If you prefer, you can open it in Excel. All right, so data A is measurement A, data B. So click on Stat, and we're going to do a tease. So we can do two sample with data, but as we already decided in this case, it is a paired. So if you do have a two sample, it's the same thing with data with summary. This is a paired, so we just have to click on paired. Our column A is sample 1. Our column B is sample 2. If you want, you can save the differences. I'll check it so you can kind of see what it is. And then we have our hypothesis checked. And we're going to have to run this again because in part C here, you see they want us to build a 99% confidence interval. So we just rerun it, the whole thing again, and just click on this and change this to 0.99. Well, let's read the problem and see what we have to do here. Is there a difference in measurement of velocity between? So when it just says difference and it is stuff greater than or not less than, this is a not equal to problem. So we could pick other options, but it is not equal because all we're doing is to know if they're different. Again, you can click on a p-value plot. You cannot click on both of these, so it changes out. So I have to do one analysis first, then the other. And then you can click on compute. Now, in this case, they don't even want all the measurements. They just want to know if we reject or do not reject. So we just look at p-value, 0.22, which is larger than our level of significance of 0.01. So we do not reject. Close this down. As you can see, now I have the differences here. So if you wanted to see how much they differ and do the formulas by hand, the differences are calculated for you, and you can do a few by hand just so you get comfortable with it if you want to. To build a confidence interval, we do the exact same thing. Click on Stat, and go to T-Stats, paired. Again, our data is in column A, sample 2 is in column B. If you want to see the difference again, well, this time I won't put it on because you already saw what that is. We're going to do a confidence interval. Make sure you always change it. So we're doing a 99, not a 95, so I'll put 0.99 in. Click compute. There's my lower limit and my upper limit. And where did my StatCrunch go? Sorry about that. Negative 8.92. Wants it in 3 decimal places. So, well, I only put in 2 and it worked, which shouldn't have, but it did. So, and then 4.39. So sometime, I don't know why I did that. It should have gave me an error. So make sure you read carefully. As you see, I didn't, but it still gave me a correct answer. If that does happen to you, please email me, and I don't redo the problem. I know you're doing the calculations correct. It's just the limitation of the software. And then choose the statement that best agrees with the interpretation of the results. Remember, confident, right? And these are written correctly. Like a couple weeks ago, we had to really go through them. You are 99, because we did a 90% confidence, 99% confident that the mean difference in the measurement lies in the interval found above, right? It's in the interval. So this one, actually none of them say 99, so that actually makes this one a little easier to solve, but that's how it is. I'm 99% confident that the true measurement lies somewhere inside of our interval. All right, so that's how you kind of use the technology. They'll walk you through some with data, some without, some paired, some two sample with the mean, some two sample with the proportions. Just read the questions that decide what type of analysis. Go through and do the calculations, and just read the questions carefully. And I think interpretation is the big thing. Even if they make you do a critical value and compare it to a test statistic, you have the p-value, and you're going to get the same conclusion. So if you prefer doing p-values, but we want you to find a critical value so we know how to do it both ways, you should come up with the exact same conclusion. Same with confidence intervals, right? So we said do not reject. And because we were confident there was no difference, which means 0 should be a valid answer. Well, our confidence interval goes from -8 to a +4. That means 0 is inside this interval. So even if we look at our confidence interval, you can see we would still do not reject. So I hope everyone has a good week. If you have any troubles with the technology or the homework, please email me, and I will be glad to assist. All right. I'll talk to you all again. Have a good day.